Today we will discuss third test in t-test, and this is known as paired t-test. It is also known as dependent t-test. So why this is called as dependent t-test? Because in this test we have to note that the two observations in two samples are dependent. So unlike the usual t-test in which the observations in the samples are independent. So in paired t-test, both the samples are dependent. Suppose if you take X be the one sample and Y be another sample, then these two samples are dependent on each other. So what are the situations in which we can use these t-test? So suppose we are interested in testing whether training is effective in improving average performance of the personnel. So for average performance of the personnel, whether training is effective or not, this we need to understand. Suppose our research problem is to know whether a bulky person's weight will get reduced after joining a health club or not. So that means joining a health club benefits for reducing the weight or not. So in this situation we can use a paired t-test. So this is the test where both the variables are dependent, unlike the unpaired t-test in which both the variables are independent. So in such a situation paired t-test is used. So what is this X? So X represents the values. X is nothing but what? So X is the observation. See, this X is nothing but the observations before applying the method. So that means before giving a training, what are the observations? So that is taken as X. Or in the second situation where the bulky person's weight before joining a health club should be taken. And what about this Y? So Y is nothing but the observations after applying a method. So that means a training should be given, a month's training should be given, and then the observations were recorded. Or so a person who want to reduce his weight, so whether the weight is reduced or not after giving a month's joining the health club. So that is nothing but my Y observations. So X observations are before applying the method and Y observations are after applying the method. Then what we have to do in this case? So see, in this case X follows a normal distribution with mean, mu and variance sigma square. So since the variable is X, therefore we can take this value as mu X and variance as sigma square X. And what about this Y? Y also follows a normal with mean mu Y and the variance sigma square Y. And now we need to take the difference between these two. So how to take the difference between these two? So normally we are taking this difference as, so this difference as yi minus xi. So y is what? So y is the observations after applying a method and x is the observations before applying the method. So take the difference and denote this difference by di. And since x and y both follows a normal distribution, so x follows normal distribution, y also follows normal distribution. Therefore, d also follows a normal distribution with mean mu d and variance sigma square d. So this is what is my test statistic and what about my hypothesis in this case, since you know that the testing procedure takes 4 stages. The first stage is hypothesis. The second stage is we have to build up a test statistics, depends upon the situation. The third is the critical region and the fourth one is a conclusion. And what is my hypothesis in this case? So in this case I want to know, so that means whether the training is effective or not, or whether a person who is joining a gym, whether he reduces his weight or not. So normally what we say in null hypothesis, that there is no significant difference between the training given to a personnel. So the performance of the training is not that much effective. So that is our null hypothesis. And in case of the second, a bulky person's weight, so we can say that the joining gym is not effective to reduce the weight of a person. So that is my null hypothesis. And what about the alternative hypothesis in this case? So we can say the alternative hypothesis that so there is a significant difference, that means the value of mu d which is not equal to 0. So mu d is not equal to 0 means what? So what we can say in this case, that the training is effective, or the joining health which reduces the weight. So that is my mu d. Otherwise we can take this as a left-tailed test or the right-tailed test. So my alternative hypothesis in this case should be, so either it is a mu d equal to 0 or mu d which is not equal to 0, which is a two-tailed test. Mu d less than 0 is my left-tailed test, and mu d greater than 0 is my right-tailed test. So next, thus the test reduces to the test for single sample, where the test statistic becomes. So what is my single sample t test, in which I can say that t is equal to x bar minus mu divided by s upon root n. So instead of x bar, since it is a two sample test and both the observations are dependent, we can say that my t becomes t bar. Instead of x bar, I can put as d bar. So what is my d bar? D bar is nothing but summation d upon n. How I can calculate the value of d? D is nothing but, so what is d? D is nothing but y minus x. So I can calculate the value, the difference between y and x, and that is nothing but my d. And if you take the summation of this column, so that is summation d is what? Summation y. So that means summation y minus x. So I can take this value and that becomes my summation d. And once I get the summation d, then divide it by n. So n is nothing but the pair of observations. So how many x and y values are there? Since it is a paired t-test, we are getting the same observations. The sample sizes of x and y are same, and we are recording the observation on a single individual. So that means a bulky person is there, and we are recording the weight before joining a club, health club, and after joining a health club. So therefore this d bar now comes out to be summation d divided by n. So that will gives us the value of d bar, and calculate this, the square root of the variance. So that is SD. So SD is equal to summation di minus d bar square divided by n minus 1. And what is my t statistic in this case? So t becomes d bar minus mu d divided by SD upon root n. And under the null hypothesis, so what is my null hypothesis in this case? Mu d is equal to 0. If I put the value of mu d equal to 0 in this case, so that becomes t is equal to d bar upon SD upon root n. And we know that d bar is equal to summation d upon n, and SD is summation di minus d bar square divided by n minus 1. The third stage is related with the critical region. So for alternative hypothesis, if the alternative hypothesis is two-tailed test, then this mod Tn minus 1 should be greater than or equal to Tn minus 1 alpha by 2. And what is this alpha? Alpha is my level of significance. For two-tailed test, we have to divide it by 2. Otherwise, for right-tailed test, we can take the same level of significance, alpha and alpha. Just what we have to do in this case, the n minus 1 should be my degrees of freedom. So that means 1 degrees of freedom should be lost, because so we need to reduce the value of n minus 1 as